Welcome back to Master Academy of Mathematics. Now this is the next continuation problem topic of your multiple integrals. So till now we completed in the multiple integrals, double integral, triple integral and change of variables into polar coordinates and change of order of the integration. The next continuation is area by double integral. So in this function is not given, no integrand is given, but with the help of double integral you are calculating area between two equations. So I am going to suppose that the procedure is you are considering only the xy plane. Always for the given problem you suppose that only in the xy plane you are calculating the area. And the equations are given y equal to some f of x and y equal to some g of x. By using that equations you solve it so that you can find out the limits of x variable. These x variable limits only in terms of real numbers, and y limits you keep as it is and find out the area between the given functions. It is the x integral, just write down the x limits, and y integral corresponding to the given equations you just write down y values and dy dx. That gives you the area corresponding to the given equations for the xy plane. Now let us have a problem. Find the area between x square equal to y and y square equal to x. So only the two equations are given and we need to calculate area between those two equations by applying double integral. So in order to find out that one, the first thing is nothing but you solve the given equations in order to get x values. I am supposing this is the first equation and here it is second equation. Now only in order to get your x values from the second equation, you just write down from second, what about the y value from second equation? It is root x. So this value you are substituting in equation number 1 so that it is x square equal to, in the place of y I am just supposing it as root x. To avoid this root x, just squaring on both the sides, x to the power of 4 equal to x, or I can write x power 4 minus x equal to 0. From that if I take x is common, it is x cube minus 1 equal to 0. By that you are getting either x equal to 0 or x cube minus 1 equal to 0. Now what are the possible values of x variable? 0 and 1. So once you get the values of x variable, now you are calculating the area. So area, it is equal to, as per the formula, double integral, you write down the x values 0 to 1. And how to write down the second integral limits? Only you are writing the y limits. From the equation y equal to x square. This is first equation. From the second equation, what is the y value? It is root x. So just you substitute first equation and second equation and directly you are writing it is dy dx. So this is equal to x is 0 to 1. Now you are, nothing is there. Integral of 1 is nothing but y. So you are writing the limits x square to root x and here it is only dx. So integral x equal to 0 to 1, the root x value upper limit and minus of the lower limit x square. It is of dx. So how to calculate this? X integration x power 1 by 2 is there. That x to the power of 3 by 2 divided by 3 by 2 minus x cube divided by 3. So you are substituting the limits 0 to 1. Upper limit, it is just 1 divided by 3 by 2, or I can write 2 by 3. Is it 2 by 3? No. So it is 1 divided by 3 by 2 minus upper limit, only it is 1 by 3. So now this is equal to, so this is equal to 2 by 3 minus 1 by 3. So the final answer is nothing but 1 by 3. So this is about your 1 by 3 area it is occupying between the given equations. So this is how you are calculating area corresponding to the two equations by applying double integral. Now let us have certain exercise problems. Find the area between y square equal to 4ax and x square equal to 4ay. Same procedure, two equations are given. From that you solve these two equations, you will get the x values and using that x values you directly find out the double integral. Write down the x limits, and y limits are nothing but from the first equation y value, from the second equation y value. And you are getting the final answer is 16a square by 3. And coming to the second problem, find the area. Instead of giving two equations, they have given only x square by a square plus y square by b square equal to 1. So in order to get only one equation is given, so to get x and y limits, the only thing is from your equation you write down only y square value. What about this y square? Y square equal to b square into 1 minus x square by a square. From that you substitute y equal to 0. You will get x values. The x values are only x equal to a you will get. That means x limits are 0 to a. And what do you think about the y value? We have calculated y square, from that y equal to. So you start with 0 to that particular value. So x limits 0 to a and y square equal to 1 minus, that is b square into 1 minus x square by a square. From that you calculate the y value. Directly you substitute in the double integral. Answer is pi ab by 4. Coming to the third problem. Find the area between y equal to 2 minus x and y square equal to 2 into 2 minus x. So anyhow two equations are given. Solve for x variable and find out the y limits. Directly answer is 2 by 3. The last problem. Find the area between, again the two equations, y equal to 4x minus x square and y equal to x. Always you remember that you are calculating only the x values, and using that x values, y values are directly substituted in the limits, and the final answer is 9 by 2. So with this, the area by the double integral topic is closed. In the next video session, we are going to enter into volume by double integral. Have a good day.